Let's start today's discussion with one question. Let's say in my sessions, I'm giving the learners a question that, which specific programming language do you like the most? And let's assume I have given few options to them. It could be Python, C, C++, and Java. And let's say almost 100 students said that we personally prefer Python programming, whether it's about implementation, doing DSA problem, or designing the websites, doing data science stuff. We prefer Python the most. Okay. The remaining 50 people mentioned Java, and apart from that, 20 people mentioned, let's say, C++, and only 10 students have mentioned that we prefer C. Now, based on this data, which I have collected, can I pre-assume that Python is the most common programming language, which is actually preferred by almost all the learners for the entire population, or it is just a random, guess with respect to the same because the available learners only mentioned this specific thing. We don't know. Now, the point is that how can we validate that Python is something which is actually preferable by the many what I can say population based data by many learners. Now this is where I think one most important thing based on statistical test will come into picture. In my playlist I have covered up uh, t test, z test, and ova test, but I have not covered up about chi-square test. Today we will discuss about that. For those people who are new on my channel, my name is Priya Bhatia, and I'm currently working as a lead data scientist at Turing. Prior to that, I have around 6 years of experience working in this domain, also teaching data science specific stuff to the learners. So please have a look onto this specific discussion where I'm talking about in detail the core idea of chi-square test. In a nutshell, we use this specific test whenever we will be having a categorical data. For example, the example which I have given right now is based out of this categorical data only, right? So I'm talking about two important things in this test. One is the observed data, which is given to us in the problem statement. And another one is the expected data, which is the kind of the assumptions, if it holds true, what kind of observations we will be able to collect. And the difference between these two is what we can say is the you know common observation part, which help us to evaluate the chi-square value. So how exactly it will work, what is the way to evaluate it, I'm showcasing in this specific discussion, uh, first of all numerically, and then via Python code as well. So please make sure that you will watch the discussion till the very end, and it will be super insightful for you all. I'm pretty sure that you have never got these kind of understanding of chi-square test in any of the available YouTube videos for free. One most important thing is that you have to watch the discussion till the very end, and do let me know in the comment section that whether you genuinely like this video or not. I usually think a lot when I publish these kind of research oriented videos, because obviously people won't like or share these videos too much. So if I have these kind of audience which support me in this specific part also, I will definitely keep on publishing these videos. So I need your support in terms of that. In my previous discussion of hypothesis testing in one shot, that video went viral. I mean, there are a lot many people who supported that video, tagged me on LinkedIn, and the similar kind of a support I am looking forward in this specific discussion as well. So with that spirit, with that assumption, with that promise that you will comment in this specific discussion video, I will start the final discussion of chi-square test. So I think we started our discussion with respect to the inferential stats in our last week class. We have seen that when we talk about inferential stats, the main focus will be that if we will be having a sample data and we will try to estimate the parameters inside the sample data, somehow those similar parameters will be a intuition behind what could be the population parameters looks like. And that's what we have covered up. After that, we started our very good discussion about hypothesis testing part, where we have seen that how the complete flow looks like. So when we apply these statistical tests, the flow is same. What is the flow? The flow is that first of all, we need to define in the very first step the null and alternate hypothesis, right? We need to define what is null and what is alternate hypothesis. Once we define the null and the alternate hypothesis, the next step will be the next step will be what have you learned from the previous discussions? The next step will be that we need to understand that what exact problem we are solving, right? Depending upon that category, what the type of distribution of data looks like, we need to define what is the type of test we have to take. So whether it could be z test, t test, today we will talk about chi-square and ANOVA test. Be it any test, we have to apply the tests over here. I will call it as a statistical test that we have to apply. Once I'll apply these statistical tests, what's the next step? Obviously, we will be able to get some measure value from this, and then from a degree of freedom and this evaluated value, we will try to measure what is p value, and we try to compare it this with alpha, the value of alpha, right? Now, alpha is what? We have understood that alpha is nothing but it's a type 1 error, right? So it's kind of how much error we are allowing in our experiment. Usually, this is the value given by domain experts. We take it as a fixed set of value in any experiment. For example, in our discussions, we have taken the value of alpha as 0.05. Now, we have seen that when we try to conclude something, so if the value of p is maybe we can say less than alpha. So what we usually do in this specific scenarios, if the value of p is less than alpha, in that specific case, what will we conclude? So either this outcome will be yes or this outcome will be no. If this is yes, what will you conclude? If the value of p, I mean, p value, we have seen that it's kind of a measure of uh, null hypothesis. So it's kind of an estimate of the probability, right? And if this value of p is really great, it is more than alpha itself. In that specific case, obviously, we cannot reject the null hypothesis. One more thing we have understood in our previous discussion that, our whole experiment, our whole analysis is entirely based on null hypothesis. Although we do have alternate hypothesis, but our main focus point will be the null hypothesis. So whenever we conclude something, we always say in terms of either we are rejecting the null hypothesis or we fail to reject it. So if it is yes, then definitely, because p value is smaller, we will go ahead and reject the null hypothesis. H0. This is another way to represent it, or you can just mention it as null hypothesis. And if this value is no, if this value is no, in that case, what we will do? We will fail to reject the null hypothesis. All right. Now, coming back to the story, today our main focus on this specific stage, where we will talk about that where exactly we have to use chi-square test and where exactly we have to use ANOVA test. So once we will be able to get a clear idea about these two tests, we will go ahead and do the implementation also side by side. But before jumping towards that, can I get a quick confirmation that the flow is clear and how basically we will be able to reach to this conclusion part is pretty much clear to everyone? Shall we proceed further? All good till so far? Can I get a quick confirmation from everyone's end? Clear, right? Okay, very good. Now, let's talk about first of all chi-square test, and after that, maybe we will go ahead and work on ANOVA test in our second part of our discussion. So, let's start our journey with respect to the chi-square test. Now, this is a very important test. You will observe that in the industries, people are using this test quite heavily. This test is also called as goodness of fit. Have you ever heard about this test before this discussion? Maybe while working with any project, or if you are an industry professional, maybe in your projects, that I have applied a chi-square test over here. Yes. So the point is same, that this also tries to claim about the population parameters, but you will apply this test whenever you are dealing with a categorical based entities or a categorical based data. Okay? You will use this test whenever you will be having a multiple categories available. That is where the chi-square test is very much beneficial. For example, so if I'll just try to open this. Mm, 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 mm. I'm looking for a use case if we have any. Otherwise, we'll create our own use case. Yeah. For example, you can see a table of eyes by hair. So we are trying to see the connection between the eyes and the hair part. So eyes are black, dark, fair, medium, red. Color is eye color is blue, brown, green. I mean, over here, what is the connection between the eye color and the hair? So that is what we're trying to understand. So we have a eye color available. We have on the column part hair color available. And because of these colors component, you know that colors are nothing but it's a categorical component. Everybody knows about it. What do we mean by categorical data? I think the very initial discussions of stats will be around that how many different types of data that we will be having. And in that, if you remember, we have talked about categorical data also. There are two major categories inside that. One is ordinal, another one is nominal. Do you guys remember that? So whenever you are dealing with more than two categories, and they could be they could be ordinal, they could be nominal, and they're trying to compare the different categories that we will be having in a given experiment, that is where your instant intuition will be that I can do it via a chi-square test. So always remember, this chi-square test will be applicable whenever you are dealing with a categorical based data, when you will be having multiple classes, multiple categories. Over here, these categorical data could be ordinal and it could be nominal. Doesn't matter. Everybody understands the difference between nominal versus ordinal. For example, the example that we have seen in the image, it's a nominal data or a ordinal data. This specific categorical data is a nominal one or a ordinal one. Can you give me the answer? Everyone? Can I get in the chat window? Everyone? Is it ordinal? So I can see people are saying it's ordinal. Is it ordinal? What do we mean by ordinal data? What do we mean by ordinal data? By the name itself, I mean, you can make a guess. Ordinal means there will be some order, there will be some priority. For example, if let's say I'm talking about a column named as education level, and inside that I have a column, maybe 12th pass, bachelor's, master's, PhD, postdoctoral. If I talk about this specific data, which contains education level, and these are the categories we have. This is a ordinal data because now I have a priority that maybe I will prioritize in terms of the research position, the people who are having a maybe a postdoctoral as comparable to PhD, then PhD as comparable to masters as comparable to bachelors as comparable to 12th pass. So I have a proper priority order. But when we talk about nominal, there is no as such ordering will be there. So when we talk about the color, whether it's a color of hair or it's a color of eye, can you make an order? Can you prioritize ki maybe this specific color will be of higher priority? Is it something which happens in real life? Can I get some answers on this? So again, my question will be, is this an ordinal type or a nominal type? Is this type of data is a ordinal data or nominal data? Exactly, it is a nominal data. Everybody agrees on this pointer? Can I get a quick confirmation from everybody's end? So whenever you are dealing with either nominal or ordinal, you will always have to think about that I can apply a chi-square test on top of it. Okay, let's go back. Now, how this test will be applicable? Let's talk about it. For that, we will understand this with the help of a numerical example. So I have one numerical example with me, and now I will try to take that example to help you better understand that how this entire flow will go. So the example looks something like this. Let's suppose, over here, this is a chi-square test. So over here, let's suppose we are saying that in the year 2010, we have measured the weights of individuals in a small city, and below is the analysis for the same. तो हमने 2010 में एक शॉर्ट एनालिसिस किया एक छोटे से शहर में, और हमने ऑब्जर्व किया कि देयर आर 3 टाइप्स ऑफ पीपल which lies under first category as less than 50 kg weight. The second category is for the people who are having a weight between 50 to 75 kg. And the third category will be the people who are having a weight more than 75 kg. ठीक है, तो उन्होंने 3 कैटेगरीज में लोगों को डिवाइड किया वेट्स के बेसिस पे, और ये उनकी कैटेगरीज थी. सो कैटेगरिकल पार्ट आ गया. वी विल बी हैविंग 3 कैटेगरीज ओवर हियर, एंड दे हैव ऑब्जर्व दैट उस सिटी के अंदर almost 20% people were having a weight less than 50 kg. Almost 30% people will have a weight between 50 to 75 kg, and more than 75 kg weight people are almost 50%. This is the distribution. Now, whether this distribution is of population data or of sample data, from this observation, whatever you are observing, whatever be the statement I have mentioned, whether this distribution belongs to a population data distribution or sample data. बताओ बताओ क्या लग रहा है प्रॉब्लम स्टेटमेंट को पढ़ के? ये जो मैं बात कर रही हूं, क्या मैं सैंपल के लिए कर रही हूं या पॉपुलेशन के लिए? ऑब्वियसली इट विल बी ऑफ अ पॉपुलेशन डेटा. मैंने कोई सैंपल के बारे में बात ही नहीं करी. तो जब मैं परसेंटेज के बारे में बात कर रही हूं, तो आई एम जस्ट सेइंग कि ओवरऑल पॉपुलेशन के विद रिस्पेक्ट 20% लोग ऐसे थे जिनका वेट 50 kg से कम था, 30% लोग ऐसे थे जिनका वेट 50 से 75 केजी के बीच में था, एंड ऑलमोस्ट 50% पीपल वर देयर जिनका वेट 75 केजी से ऊपर था. एंड दैट्स द होल इनसाइट्स. जस्ट गिव मी अ सेकेंड. इज इट फाइन? अब क्या हुआ कि फ्रॉम 2010 टू 2020 what happens is they started taking the similar observation कि पिछले 10 साल में कुछ चेंजेस हुए हैं या सब सेम ही रहा. So what they have done is they have taken a sample of 500 people. They have taken a sample of 500 people. And what they have observed that in that same small city, when we talk about less than 50 kg, when we talk about 50 to 75 kg, and when we talk about more than 75 kg, the number of people are 140, 160 and 200. ठीक है? The question is, which the researchers are asking from you as a data scientist, ki, do we have a population difference of weights or not? So the question they're asking is that do we have a population difference of weights has changed in the last 10 years or not? So this is the problem statement. कैसे करें? The question is कि पिछले 10 साल के बीच में क्या जो ये प्रोपोर्शन रहा पॉपुलेशन डेटा का वो चेंज हुआ या सेम रहा? अब मेरे पास तो यहां पे सैंपल डेटा जो 10 साल बाद का है, 500 सैंपल्स का. अब मैं कैसे एनालाइज करूं कि कंक्लूजन क्या है? क्या दोनों का प्रोपोर्शन सेम है या दोनों का प्रोपोर्शन अलग अलग है? इज द प्रॉब्लम स्टेटमेंट इज क्लियर टू एवरीवन? इज द प्रॉब्लम स्टेटमेंट इज क्लियर टू एवरीवन? टेल मी. अब अप्रोच कैसे करेंगे आई विल लेट यू नो, बट प्रॉब्लम स्टेटमेंट क्लियर है सभी को? व्हाट आई एम ट्राइंग टू कन्वे ओवर हियर. अब इसमें काय स्क्वायर टेस्ट को लगेगा क्योंकि आप क्लियरली देख पा रहे हो कि वी हैव 3 कैटेगरीज ओवर हियर. कैटेगरी C1, कैटेगरी C2, कैटेगरी C3. अब यहां पे ये जो आपके पास एग्जिट नंबर्स है 2020 के पास में कि लेस देन 50 केजी में 140 पीपल है, 50 से 75 केजी में 160 है, 75 केजी के बियॉन्ड 200 पीपल है. This is something which obviously you can call it as a observed observation. ये एक observed value है, right? This is the observed data that we will be having. अगर मान लो proportion change नहीं होता, अगर मान लो proportion change नहीं होता 2010 से 2020 के बीच में, तो हमारे पास में expected data क्या होता? कोई बता सकता है मुझे? What should be the expected data ideally in that case? इजी है, थोड़ा सा मैथ्स लगाना है. लेस देन 50 केजी के अंदर, 50 से 75 केजी के अंदर, एंड मोर देन 75 केजी के अंदर. क्या होता? वेरी गुड, वेरी गुड. सो 100, 120 कैसे आया? आई एम नॉट श्योर. तो कैसे पता लगाओगे? यू विल बी लाइक कि ठीक है, ये तो बड़ा आसान सा काम है. एक्सपेक्टेड डेटा बता रहा ना. मुझे पता है कि 2010 में पॉपुलेशन डेटा का डिस्ट्रीब्यूशन कैसा था. 20% लोग लेस देन 50 kg में थे. तो अगर मैं यहाँ पे 500 सैंपल्स को लेके चलता हूं, है ना, अगर मैं यहाँ पे 500 सैंपल्स को लेके चलता हूं तो 20% ऑफ 500 कितना होता है? क्या हम नंबर निकाल सकते हैं? क्या हम वैल्यू निकाल सकते हैं? व्हाट विल बी द वैल्यू ऑफ 20% ऑफ 500? करो इवेल्युएट. 20% ऑफ 500 कितना हो गया? इट विल बी 100. यस और नो? यस और नो? या आपका एक्सपेक्टेड है? अगर कुछ चेंजेस नहीं होते तो आपका एक्सपेक्टेड कितना होता? दैट इज द नंबर यूर गेटिंग. सिमिलरली क्या हम बाकी की दो वैल्यूज निकाल सकते हैं? 30% ऑफ 500, दिस इज 150. Similarly, 50% of 500. 50% of 500. This is 250. हो गया? ऐड करोगे तो क्या आंसर आएगा? 500 आएगा. Just verify once and let me know, is this all right? Are we able to understand observed data and expected data, how we evaluate that? Now we are ideally able to start that same flow which we have discussed in the starting of the session, the usual flow that we do in almost all the different types of tests. Ki firstly, we have to define what is null and alternate hypothesis. So when we talk about null hypothesis, can anyone guess what will be the null hypothesis? What will be the null hypothesis? Can anyone guess? क्या होगा null hypothesis? It says कि जो आपका ऑब्जर्व्ड है टेबल और जो आपका एक्सपेक्टेड है वो दोनों इक्वल होंगे. इट सेज कि पॉपुलेशन डिफरेंस ऑफ वेट्स आर ऑलमोस्ट सेम इन द लास्ट 10 years, right? Remember that tip I told you that whenever there is a equivalent thing, usually it comes under a null hypothesis. What will be the alternate hypothesis? What will be the alternate hypothesis? What will be the alternate hypothesis? It says that, hey, the observed values that you are getting and the expected, they are not equal. They are not equal. Okay. What will be the second step? Second step, as we have seen, is to decide which type of test we have to use. And we know that, okay, for now we have to use a chi-square test. Now, when we talk about chi-square test, so we need to evaluate now what is the value of chi-square. This is how the representation of chi-square looks like. And the formula is that, hey, whatever be the observed value that you have, whatever be the observed value that you have, minus whatever be the expected value that you will be having, whole square, divided by whatever be the expected value that you will be having, right? So what is the observed value? What is the observed value? This is the observed value. This is the expected value. For each category, we will be having the observed value and we will be having the expected value. Now, I hope you understood कि हमने expected data क्यों निकाला सबसे पहले, है ना? क्योंकि chi-square की final statistical value निकालने के लिए we need both these values. So, can I start? So, it will be 140 minus 100 divided by whole square divided by 100 plus second category में observed और expected कितना है? Observed is 160, expected is 150. So you will say 160 minus 150 whole square divided by 150. Third case में, third category में, what is the observed and what is the expected? 200 and 250. So you will say it will be 200 minus 250 whole square divided by 250. Can you solve this and let me know what is the answer we are getting? Can anyone solve this and let me know what is the answer we are getting? Just do it फटाफट से and let me know the final result. Maybe we can use Kelsey. Okay, so it's around 26.66. Okay, makes sense, makes sense. Okay, so we are getting the value of chi-square as 26.66. Now, the next part is, what is degree of freedom? I hope we know the concept of degree of freedom. I hope we know the concept of degree of freedom. Yes or no? Do we know? So over here, how many number of categories we have? It's 3. So if I'll say what is the degree of freedom, it will be 3 minus 1, which will be 2. It could be the case that when you are solving a problem of chi-square test, you will be having multiple rows also. For example, right now, we just have one row because our main focus is to get the percentage of population data in terms of weights. But it could be the case that you're dealing with multiple parameters, maybe weight, height, and so on. So, ideally speaking, the degree of freedom in chi-square test will be how many number of rows you have minus 1 multiplied with how many number of columns you have minus 1. But just in case if you don't have any rows, for example, in today's session, we are not having currently any different parameters. We're just focusing on the percentage of weight. We just have the columns. We just have the categories. So that is the reason we will be having the number of the degree of freedom as 3 minus 1, which will be eventually equivalent to 2. If I'll say what will be the value of P, what is P value? Acha, we are assuming over here, as I usually say, ki whenever the value of alpha is not given, so you can consider the value of alpha as a constant 0.05. Now, the only thing that is left is we need to evaluate the value of P. So we can open our P value calculator. We can go ahead and just write the values for the chi-square. Can you see P value from chi-square? Write your chi-square value, it is 26.66. Write your degree of freedom value, it is 2. Compute the value of P. It is coming it as 0.3 times 0, right? 1, 2, 3. And then 1. So we are having the P value as 0.0001. Now I can compare, the last step is to compare these values, right? The last step is to compare this value. So P is definitely less than alpha. So what should we do? Because the value of alpha is 0.05, the value of P is 0.0001. So क्या करना चाहिए मुझे specific scenario में? What should we do? It will be, we have to reject the null hypothesis. That's the whole point. Is it all right? All good? Any doubts, any questions anyone is having? Any doubts, any questions anyone is having? Tell me. All good? The flow is clear? Hmm. बताओ, कुछ क्वेश्चन डाउट है तो पहले वो डिस्कस करो एंड देन वी विल प्रोसीड फर्दर. Is it fine? Is it okay? Shall we proceed further? No confirmation. No confirmation. कुछ इशू? One significance of chi-square test. Significance तो fix है ना? Varukapula, Kapula. So over here, if you will see, the value of alpha is the significance value. Are you talking about this value? This is something which is fixed. This is the error rate, which we have discussed as a type 1 error. So what exactly talking about? Are you talking about degree of freedom? Importance. What importance? Okay. Importance of chi-square test. So chi-square test is just like another statistical based test, but when exactly you have to use it wherever you want to compare multiple categorical classes. You want to compare a problem. For example, just now we have seen a problem where you will be having some observed data and you will be having some expected data. Again, you are trying to evaluate the population parameters only over here, but it's just that you are having a categories over here. So, for example, in this specific case, when you are saying that I'm rejecting the null hypothesis, what is the conclusion you are trying to make? What is the conclusion you're trying to make? You are saying indirectly that, hey, there is a there is a somehow change in the weights of in the weights of individuals during the last 10 years. So basically, this insight which you are giving, is this insight for a sample data or a population data? In this problem, this insight which you are concluding right now after doing the chi-square test, is this applicable for a population data or for just 500 samples that we have taken for a complete population data? So the same thing you're doing over here. Whatever test you're applying, your main focus in inferential test is to get a parametric value for the entire population. It's just that our ways are different. Why our ways are different? Because of the different type of data that we're working with. One more thing, by default, you will observe that when we talk about the chi-square test, if you will see the distribution of it, let me showcase you. You will observe that how the chi-square distribution looks like. Can everybody see that? Can everybody see that? How the chi-square distribution looks like? It is, come on, it is which type? We know this, come on. We have learned all these things in our statistical classes. This type of distribution is called as one tail is fine. I mean, we can have two tails as well, but what is the type of distribution? Skewed. Which type of skewness is there? Again, I have to ask multiple questions to reach to the final answer, huh? Right skewed. So always remember that by default, the distribution of this chi-square test is a right skewed distribution. It is a right skewed distribution. Done? I want to share with you one more important point, which I have not shared in the last class, in my last discussion. The concept of critical value. We have discussed and concluded our entire numerical problems with the help of a p value, which is quite fine. But there are two ways to make a conclusion. Either you can compare the value of alpha with the p value, the way we have done, or you can evaluate something called as critical value. So, what do we mean by critical value? This is the area. For example, when you say alpha is 0.05, in this specific case, it means you're talking about that 5% area, right? So, you are saying over here that if my critical value, so whatever be the chi-square value I am evaluating, which is coming it as 26.66, this value I will compare with this marker. If you will be able to evaluate exact this marker also, which we call as critical value, and if my chi-square evaluated value is beyond critical value, means under this specific range, so this is my rejection area, right? This is my rejection area. So I will reject the null hypothesis. And if it lies under this 95% wala zone, this is where I will fail to reject my null hypothesis. Now, how will we evaluate this critical value? P value, we did the evaluation via the calculator. Critical value we can evaluate from the tables that we have. So with respect to t-test, z-test, chi-square test, ANOVA test, we have the tables available. For example, although you will get the same results, but I'm just trying to showcase you both the ways so that in future, if somebody will ask from you, at least you will not get confused ki I'm not aware about the second approach. For example, you will say ki chi-square PDF table. Let's say you mentioned that, and I think we will easily able to access it. This is the table we have, right? So over here, let's say we are saying chi-square value for 0.005 alpha value, and our degree of freedom was 2, right? Our chi-square value was, alpha value was 0.05, not 0.005. So maybe we have to look for this specific answer. So if I'll ask you, what is the critical value over here? Can you see the answer? It is 5.991. Can everyone understand this value? So at alpha as 0.05, chi-square value with the degree of freedom as 2 will be 5.991. So from the table, you will be able to evaluate what is the exact boundary line beyond which, if my evaluated value lie, I will reject the null hypothesis. So over here, you can see your critical value is 5.991, your chi-square value is 26.66. Because your chi-square value which you're evaluating is really high as comparable to the critical value. So where exactly it will fall in this diagram? Will it fall towards the right side or the left side? Will it fall towards the right side or the left side? Can you give me the answer? It's quite obvious that because my chi-square value is 26.66, it should fall ideally towards the right side of 5.991. And that is the reason over here we will reject the null hypothesis. So you will observe that my conclusion is same. In the above part also I have rejected, and in the below part also I am rejecting. But the approach is a bit different. Over here I am comparing the critical value with the chi-square value. In the above part, I was comparing the value of P with alpha. Is it all right? Now, it all depends on you, whatever way, whatever approach in the step number 4 you want to get, accordingly, you will get the results. Results at the final end, as the conclusion end, will be same. It's just that either you have to use a p-value calculator to get the p-value with the given chi-square and degree of freedom, or you can evaluate a critical value from the available tables that we will be having. Is it all right? Is it okay? Shall we proceed further? Do we understand the meaning of critical value? Critical value is the exact value, exact boundary line. P value is the probability. That's the only difference that we have. All good? थोड़ा सा आगे बढ़े. If you have any questions till so far, please ask. Otherwise, now we can proceed to the next problem. So this is the first problem, just to illustrate the core idea of chi-square test. The main intuition is everything is actually remain the same. You have to understand that how to get the evaluated chi-square value and what exact values you need to evaluate it. And we have seen for that we just need what is the observed value we have, summation of what is the observed value that we have minus what is the expected value we have, whole square divided by what is the expected value that we will be having. Is it all right? Once we get that value, as I have mentioned, you have two things to do in the tests part. So what are those two things? Either you can evaluate the p value and compare it with alpha, or whatever be the chi-square value you get, you evaluate the critical value from the table and directly compare it with chi-square value. With both the ways, whatever be the result you will get will be same. It's common. All good? Are we getting the clear picture of it? Shall we move to the next problem now? Now, the next problem, we will try to evaluate via a code perspective. And in a numerical perspective, you have to do it at your home. So that is kind of a task for you all. So shall we start understanding that? Shall I talk about that problem? So one problem, numerically, I have solved it for you. Now, I will share with you the problem. I will showcase the practical implementation of that problem. But numerically, you have to do it at your end. That is the task for you all. So shall we proceed further? All right. All good till so far? Yes? Okay. So this is the task number 1, which I'm sharing with you all for today. Read this. Read this. Imagine you are a data analyst and you're working for a retail company. This is the problem which was asked personally to me in one of the interviews few years back. So read it very carefully. Imagine you are a data analyst working for a retail company. The company wants to know if customer preferences for different types of products are evenly distributed across different age groups or not. ठीक है? So company जो है, they eventually wants to know कि जो customer की जो preference है अलग अलग products के प्रति, क्या वो evenly distributed है across a different age group, या फिर age का बहुत बड़ा impact होता है? What do you think? Evenly distribution होता है या फिर age का evenly distribution नहीं होता? So आपको इसी के बारे में चीजें करनी है. You have to investigate this and To do that, you just did one survey. उस सर्वे में आपके पास जो रिजल्ट्स आए, and you can see these are the results which you are getting. So you will observe these are the, क्या हुआ, ठीक है? तो ये जब लोगों ने सर्वे किया, सो दीज आर द रिजल्ट्स दे गॉट. प्रोडक्ट्स हैं 3: इलेक्ट्रॉनिक्स, क्लोथिंग, होम गुड्स. आपको जो कॉलम पार्ट पे दिख रहा है दैट इज द एज डिस्ट्रीब्यूशन. एज की कैटेगरीज हैं अंडर 30, 30 to 50, ओवर 50. So it means that if I talk about the total products, you will observe that I have 100 products of electronics, 100 products of clothing, and almost 100 products of home goods. So in total, I will be having 300 products over here. In total, I will be having 300 products over here. So that is the first and the foremost thing that we will be having. Question देख लो ध्यान से. Question ये कहता है कि is there a significant relationship, significant association between the age group and product preferences? क्या जो अलग अलग एज ग्रुप है और जो अलग अलग प्रोडक्ट प्रेफरेंसेस हैं, इन दोनों के बीच में कनेक्शन है या नहीं है? इन अदर वर्ड्स, डज द टाइप ऑफ प्रोडक्ट कस्टमर्स प्रेफर डिपेंड ऑन देयर एज ग्रुप, और इज देयर प्रेफरेंस इंडिपेंडेंट ऑफ एज? क्या हमें क्वेश्चन क्लियर हो रहा है? इज दिस समथिंग व्हिच इज क्लियर टू एवरीवन? इफ यस, can you just let me know what is the null hypothesis and what is the alternate hypothesis in this case? If yes, can you just let me know what is the null hypothesis and what is the alternate hypothesis in this case? Null hypothesis is that, hey, there is no as such connection between the age group and product preferences. Means they are independent, right? So you can say that there is no association between the age group and the product preferences. Means they are independent. But H1 says that, hey, there is an association. What H1 will say, what alternate will say, that they are connected. So it says that, hey, there is an association between the different age groups and the product preferences. And that is the whole point. Now, you will apply a chi-square test because now you will be having 3 different categories. You will observe that these products are also of 3 categories, and this age is also categorized into 3 categories. So this table which you're observing over here is called as observed data. But you need to evaluate what is the expected data that we will be having. So how will we evaluate that? That's the next question. Can anyone guess what will be the expected data in this specific case as per the entire question that we will be having? Read this problem again. What is their belief? Their belief was that the different type of products that we are observing are evenly distributed across different age groups. Means there is no connection. So what will be the expected data as per their belief? Can you guess? Anyone? What will be the expected data as per their belief? So if we will be having products over here, uh, again, three products that we have: electronics, clothing, and home goods. And we will be having the age under 30, 30 to 50, and more than 50. Tell me, what will be the result? देखते हैं कौन बता पाता है इसको. All values should be equal. Exactly, Kalpesh is right. But what were those values? Kalpesh, evenly spread कैसे करोगे इसको? Can I say total value is 100? प्रोडक्ट्स कितने हैं? 100 है. हर एक प्रोडक्ट कितना है? 100 है. और कितनी कैटेगरीज है? 3 कैटेगरीज है. सो कैन आई से इवनली स्प्रेड का मतलब हुआ 100 डिवाइडेड बाय 3. तभी तो एज और प्रोडक्ट्स के बीच में कोई कनेक्शन नहीं होगा. सेम थिंग विल बी ओवर हियर. 100 डिवाइडेड बाय 3 and same thing will be over here. 100 divided by 3. क्या ये बात सही है? Can I say this, everyone? Is this something which is all right? यही तो हमने बोला. यही तो इनका बिलीफ था. There is no association between the age group and product preferences. Means they are independent. Independent कब होंगे? जब तीनों की वैल्यूज इवनली स्प्रेड होंगी, इवनली डिस्ट्रीब्यूटेड होंगी. अब हो सकता है कि ऐसा हो सकता है कि ऐसा ना हो सकता है कि देयर इज एन एसोसिएशन, हो सकता है देयर इज नो एसोसिएशन. Makes sense, right? Now, obviously, at your home, what you have to do? You have to evaluate what is the observed minus expected whole square divided by expected. Do the summation of that. Evaluate the value of chi-square. Evaluate the value of degree of freedom. Acha, what will be the degree of freedom in this case? So, chi-square value you will evaluate as the summation of what will be the value of, let's say, observed minus expected whole square divided by expected. This is fine. This is fine. The second part will be you have to evaluate the degree of freedom. Can anyone let me know what is the degree of freedom we have? Can anyone let me know what is the degree of freedom that we will be having? Guess. थोड़ी देर पहले हमने डिस्कस किया द कॉन्सेप्ट ऑफ डिग्री ऑफ फ्रीडम, हाउ वी इवेल्युएट इट with respect to chi-square test. So what will be the degree of freedom in this specific case? Very good. Very good. It's 4. Kalpesh is mentioning in a very much appropriate way. So it is nothing but how many number of rows minus 1, how many number of columns minus 1. Because in this case, we have rows also. We have different products also, right? So we have 3 products. 3 minus 1 is 2. We have 3 age specific categories. 3 minus 1 is 2. So we will get the answer as 4. So you will evaluate. Now you can evaluate the p value maybe, or you can evaluate the critical value. If you are evaluating a p value, then you can just go ahead and compare this p value with alpha. If it is smaller than alpha, you can simply go ahead and reject the null hypothesis. Otherwise, otherwise you will fail to reject the null hypothesis. And finally, if it is a critical value, you need to compare it with a chi-square value. And if chi-square value is quite bigger, then again, same thing, you will simply go ahead and reject null hypothesis. Otherwise, you will simply fail to reject the null hypothesis. And that's the whole aspect of it. All good? Is it all right? So, this is something which you have to do as a task, although I have done a lot of things for you and I have explained the problem statement. I have done the initial steps also. Now it's just that the calculation is required from your end. But now what will I do is I will try to implement this problem in a mathematical aspect. Okay? So shall we go ahead and implement this problem? Are you guys ready? करें implement? Implementation बड़ा आसान है. As usual, we just have to make use of that SkyPy libraries that we will be having, and things will be easy for you to implement. It's just that understanding is something which could be difficult to grasp, but if you will pay attention, whatever I'm trying to convey over here, then things will be easy for you. So whatever pointers I have discussed right now, in terms of a numerical part, is this something which is clear to everyone? Can I get a quick confirmation? Null hypothesis statement will be negative always. No, no. It's not about negative or positive. It's about what we believe will be the null hypothesis and its opposite or its contradictory is the alternate one. I have mentioned in the past that बहुत बार जब हम इक्विवेलेंट की इक्वेशन को यूज करते हैं, फॉर एग्जाम्पल म्यू ऑफ सैंपल इज इक्वल टू म्यू ऑफ पॉपुलेशन, equal and not equal usually comes under null and alternate. So that is something which is maximum number of times we have a representation of. But if you're trying to specify in terms of the lines, the equations, the statements which I'm trying to convey right now, in that case, just see that what is their belief, what exactly are they expecting, and opposite to that will come under the alternate one. So positive negative wala aspect ko mat rakho, because then there will be a confusion. You have to read the problem statement very carefully. You have to see that what is their belief, and that is something which will be a part of a null hypothesis, and the contradictory of that is something which will be a part of a alternate one. Is it all right? Is it okay? Shall we move further? ठीक है. Now, Let's go ahead. I will try to open one collab file and solve this problem, second problem that we have discussed. So today will be a discussion on chi-square ANOVA. So it will be of 11th of perfect. Let me open one Google Colab. So what we will do is we will try to first of all paste the numbers which are available in the table, and then on top of it we'll try to evaluate the chi-square value. Hmm. ये सब जो हम पढ़ रहे हैं ना statistically, these are more frequently used in the research perspective. So this knowledge is required in those specific scenarios. So when you're applying for data science specific job roles, and specifically if they're working with machine learning specific projects, uh, most probably over there this kind of knowledge will be quite heavily required. Or if they're hiring you for a research specific positions, that is where also things will be required, whatever we're learning right now. So over here, what we can do, we can simply go ahead and first of all, let's import all the required libraries. So let's import all the required libraries. So we will import NumPy. We will import SkyPy dot stats. And after this, what we will do is, let me just copy the problem statement. So I'm just writing over here again so that when you refer this file, you know that why we are solving this, right? So over here, you conduct a survey and collect the following data. So data is something which we have to now copy in our code part. So this is something which you can call it as a observed data, and you can store it in the form of a numpy array. I think that's a very good data structure to store this kind of numeric values in a table form. So we can have a two-dimensional array. Now, can you just let me know what are the exact numbers in different age groups we have? I think it was 50, followed by 30, followed by 20, right? Then I think we had a second row. And what were the values we have in the second row? It was 30, 30. Then we have 40, and then we have again 30, 30. Then we had the third row, which includes 20. Then we had 30, 30. What's next we have? Then we had 50, 50, 50. Done. So this is the observed data that we have. So this is fine. Now, what we want to do is we want to perform the chi-square test. We want to perform the chi-square test. So what we want to find out is the value of chi-square statistical value. I'm working with p-value, so I want to find out the p-value. I want to find out the degree of freedom. I want to find the expected value. So over here it will be stats dot um, chi-square, there is a function called as contingency. We will use this function, and you have to mention what is the observed data that you will be having. Now, when we talk about this specific function in the SkyPy, uh, you will be able to observe that it will automatically take that as an expected value, which we are talking about, equal proportion distribution. So over here, if I can showcase you. Um, you can see the expected frequencies are computed based on the marginal sum under the assumption of independence. So over here, whenever there is a question around the two factors that we have, for example, यहाँ पे question क्या था कि products और age जो है वो आपस में independent है या नहीं, right? Independent कब होंगे? जब evenly spread होगा. तो तब आपको हमेशा ये chi square underscore contingency function को ही use करना है. So what we are doing is we are performing the chi square test of independence in a way to understand that whether the two fields that we will be having, which is products and age, are they independent or not. So I have used that contingency function. Now you will be amazed to see that when you try to print the different values, or maybe I will do in the next phase, if I will try to showcase you what is the value of chi-square stat. You can say it's around 30 because they might have taken an approximation. Uh, you can just verify when you solve it numerically. Just in the next session, let me know कि जो आपकी वैल्यूज आ रही हैं वो एग्जैक्टली 30 आ रही है, अप्रॉक्सीमेट 30 आ रही है या नहीं आ रही. बट यू विल ऑब्जर्व ओवर हियर, इफ आई विल जस्ट ट्राई टू प्रिंट व्हाट इज द एक्सपेक्टेड वैल्यू, या फिर इसको आप एक्सपेक्टेड डेटा भी बोल सकते हो क्योंकि ये एक टेबल है ना, जो कि इवनली स्प्रेड होनी चाहिए. मैं इसको फिर से रन करती हूँ एंड यू विल ऑब्जर्व. कैन यू सी इट इज अराउंड 33.33. अगर आप, मैंने क्या लिखा था एक्सपेक्टेड डेटा में, 100/3. अगर आप कैलसी ओपन करके चेक करो, 100/3, it is around this value only. So can you see it is taking the appropriate expected data as well? So I'm pretty sure that this chi-square statistical value is also very much apt. Then if you want, you can also print what is the p value they are getting, and you can then compare the p value with your values. One thing to understand that over here, this value is very, very small. It is e to the power of minus 0.6. So you can consider that this is very, very small. So if you're getting a p value as 0.000 something, so don't get confused with that. Okay? And if I'll just try to showcase you how the degree of freedom looks like, so you can compare this. I hope this is also we have understood. Degree of freedom 4 होनी चाहिए. क्यों होनी चाहिए? Because 3 हमारे पास products है, 3 हमारे पास categories है. So 3 minus 1 is 2, 3 minus 1 is 2. When we multiply that, we'll get the answer as 4. And that's the overall point of this discussion. So क्या अगर मैं अब फाइनल कंक्लूजन की तरफ जाऊं, if we'll go towards the final conclusion part, so we can say if, so let's define the value of alpha as 0.05, and we can say if the p value that we're getting, if it is less than alpha, we will go ahead and reject the null hypothesis. Else, we'll go ahead and print that, hey, we fail to reject the null hypothesis. Is it all right? Done. Done. So you will be able to observe that over here, because the p value is way smaller than alpha, that's the reason we will be able to reject the null hypothesis. Is this good? Is this fine? तो अगर आप बोल रहे हो कि आई एम rejecting the null hypothesis, what does that mean in terms of our problem statement? इसका मतलब क्या हुआ? आपने नल हाइपोथेसिस में क्या बोला था कि वो इंडिपेंडेंट है, देर इज नो एसोसिएशन. अब आप इस स्टेटमेंट को रिजेक्ट कर रहे हो अपने एक्सपेरिमेंट के बाद में. इट मीन्स दैट यू आर सेइंग, so when you are saying that I am rejecting the null hypothesis, it means that there is an association between the age group and the products, right everyone? और ये बात सही भी है, क्योंकि अलग अलग एज के हिसाब से यूजुअली लोग अलग अलग प्रोडक्ट्स खरीदते हैं. मे बी जो यंगस्टर्स होंगे वो बहुत ज़्यादा इलेक्ट्रॉनिक प्रोडक्ट की तरफ इंक्लाइंड होंगे या क्लोथिंग की तरफ इंक्लाइंड होंगे. जो एज्ड लोग होंगे वो शायद इतना ज़्यादा इलेक्ट्रॉनिक आइटम नहीं खरीदेंगे. और जो बहुत ही ज़्यादा यू नो अंडर 30, 30 to 50, over 50, so maybe जो अंडर 30 होंगे, मे बी दे आर मोर इंक्लाइंड टूवर्ड्स बाइंग more electronics item, lesser home goods, right? So depending upon different ages, there is a dependency, there is an association with the products part. So I hope we can agree with this pointer, practically also, realistically also, and experimentally whatever we have done with that also. With that, our chi-square test part is over. Whatever conversation we have done, I hope that you get an idea about this entire test now. It's very important, very heavily used in the industries. So if you will just go ahead and check now chi-square test, you can just read it out once as a final conclusion part. So you can see a chi-square test is a statistical hypothesis test used to determine if there is a significant association between a categorical variables, or if your observed data fits an expected theoretical distribution. It analyzes count data comparing what you actually observed with what you would expect by pure chance. कितने लोगों को ये डेफिनेशन, ये सब डिस्कशन करने के बाद क्लियर हो रही है? How many of you are getting this entire definition? अब तो हो रहा होगा क्लियर. We have seen a very good example. I think two examples we have seen, and we have solved it practically. We have solved it via implementation also. So if you have any doubt after reading this whole definition now, अगर मैं सबसे पहले ये definition आपको खोल के दिखाती और फिर हम आगे बात करते तो you'll get confused कि ये क्या क्या words आ रहे हैं. बट अब हमने सब कुछ कर लिया, एंड आई एम एंडिंग माई दिस chi square टॉपिक विद दिस डेफिनेशन. आई थिंक नाउ इट शुड बी क्वाइट क्लियर एंड यू माइट फील कॉन्फिडेंट कि हाँ अब मुझे समझ में आ रहा है कि हमने एक्चुअली में किया क्या है इसमें, राइट एवरीवन? इंटरव्यूज में काफी इंपॉर्टेंट टेस्ट है ये, स्पेशली इफ यू आर अप्लाइंग फॉर डीए स्पेसिफिक जॉब रोल और डेटा साइंस स्पेसिफिक जॉब रोल. सो प्लीज हैव अ लुक ऑन टू इट. और दुख की बात यह है कि आपको बहुत अच्छी एक्सप्लेनेशंस ऑनलाइन नहीं मिलती इसकी, राइट? इन जनरल स्टेटिस्टिकल टेस्ट्स के बारे में ही कम देखने को मिलता है. पीपल यूजुअली टॉक अ लॉट अबाउट डिस्क्रिप्टिव स्टैट्स, बट इन्फरेंशियल स्टैट्स बहुत अच्छे से समझ में लोगों को नहीं आता बिकॉज ऑनलाइन रिसोर्सेज काफ़ी कम है. सो प्लीज हैव अ लुक ऑन टू इट very carefully and let me know if you have any doubts, any questions till so far. Otherwise, give me just thumbs up ki yeah, we are clear, we are good, so that we can proceed further. Nazia, do you have any question? You have raised the hand. I have shared you the permission to talk. ललित, क्या रिपीट करना है? 1.5 घंटे से बोला है, अब इसमें फिल्टर करके बताना पड़ेगा रिपीट क्या करना है. क्या क्लियर नहीं हुआ? बेसिकली हमने यहाँ पे लेट मी गिव अ क्विक समराइजेशन ऑफ व्हाट वी हैव डन. हमने यहाँ पे काई स्क्वायर टेस्ट को लेके समझा है ना. सो वी हैव सीन कि काई स्क्वायर टेस्ट सबसे पहले हम लगाते कब है, जब हमारे पास कैटेगरिकल डेटा होता है, जब हमें कैटेगरीज को कंपेयर करना होता है. कैटेगरीज में क्या कंपेयर करना होता है? एक हमारे पास ऑब्जर्व डेटा होता है, एक हमारे पास एक्सपेक्टेड डेटा होता है. हमें ये कंपेयर करना होता है कि क्या वो दोनों वैल्यू सेम है या सेम नहीं है. दैट इज द मेन पॉइंट. काई स्क्वायर दोनों के बीच का डिफरेंस निकालता है. सो द फॉर्मूला सेज इट इज समीशन ऑफ ऑब्जर्व्ड माइनस एक्सपेक्टेड स्क्वायर डिवाइडेड बाय एक्सपेक्टेड. तो हम वो निकालते हैं इस फॉर्मूले की हेल्प से. हमारे पास काई स्क्वायर की एक स्टेटिस्टिकल वैल्यू इस फॉर्मूले से आ जाती है. नेक्स्ट काम हमारा होता है डिग्री ऑफ फ्रीडम निकालने का. डिग्री ऑफ फ्रीडम होता है कि कितनी इंडिपेंडेंट वैल्यूज हैं कंसिडरिंग द सैंपल विच वी विल बी हैविंग. सो इन जनरल आपका फॉर्मूला होता है जितनी भी नंबर ऑफ वैल्यूज है -1. क्योंकि यहाँ पे हमारे पास रोज में भी डिफरेंट कैटेगरीज हो सकती हैं और कॉलम्स में भी. तो वी आइडली सेट एज रो -1 एंड इनटू कॉलम -1. बट अगर आप कोई ऐसा क्वेश्चन कर रहे हो जहां पे आपके पास सिर्फ कॉलम्स हैं, सिर्फ कैटेगरीज दे रखी है, रोज में एक ही रो पे हम काम करते हैं, तो यूजुअली वी टेक इट एज अ कॉलम -1 एज वेल. तो फर्स्ट प्रॉब्लम में हमारे पास सिर्फ कैटेगरीज थी, 3 कैटेगरीज थी वेट के डिस्ट्रीब्यूशन के बेसिस पे. सो द आंसर वाज 2. काई स्क्वायर और डिग्री ऑफ फ्रीडम की हेल्प से वी इवेंचुअली गो अहेड एंड ट्राई टू फाइंड आउट द पी वैल्यू. पी कैलकुलेटर से हमारे पास ये वैल्यू निकलती है और फिर हम इसको कंपेयर करते हैं अल्फा से. ये सेम काम है जो हमने लास्ट क्लास में टी टेस्ट और जी टेस्ट के लिए किया था कि अगर पी वैल्यू अल्फा से छोटा है तो मतलब रिजेक्ट कर देंगे, अदरवाइज हम फेल टू रिजेक्ट कर देंगे. दूसरा तरीका मैंने आज बताया कि अगर आपको पी वैल्यू नहीं निकालना तो आप डायरेक्टली भी कर सकते हो. आपके पास काई स्क्वायर वैल्यू तो है ही, आप क्रिटिकल वैल्यू निकाल लो. क्रिटिकल वैल्यू कैसे निकालेंगे? क्रिटिकल वैल्यू होता क्या है कि जब आप डिस्ट्रीब्यूशन की तरफ जाते हो, सो फॉर एग्जांपल अगर आपने ये ऑब्जर्व किया, वी हैव सीन कि काई स्क्वायर का बाय डिफॉल्ट जो डिस्ट्रीब्यूशन होता है इट्स अ राइट स्क्यूड डिस्ट्रीब्यूशन. तो हमें पता है कि राइट स्क्यूड डिस्ट्रीब्यूशन के अंदर अगर अल्फा की वैल्यू 5% है तो राइट एक्सट्रीम जो 5% एरिया है वो रिजेक्ट वाला एरिया है, बाकी 95% एरिया एक्सेप्ट वाला है. तो ये जो एग्जैक्ट वैल्यू है, जो बाउंड्री लाइन है, इसको मैं क्रिटिकल वैल्यू बोलती हूँ. इसको निकालने के लिए मुझे टेबल को रेफर करना पड़ता है. तो अगर मुझे टी टेस्ट लगाना है तो टी टेस्ट की टेबल रेफर करूंगी. अगर मुझे जी टेस्ट लगाना है तो जी स्कोर की टेबल रेफर करूंगी. अगर मैं काई स्क्वायर टेस्ट लगा रही हूं तो मैं काई स्क्वायर की टेबल को रेफर करूंगी. एंड इन दैट टेबल आई हैव जस्ट पास 3 वैल्यूज. अगर मेरे को 2 वैल्यूज अगर मुझे पता है तो मैं निकाल सकती हूँ. क्या क्या? डिग्री ऑफ फ्रीडम कितना है, और आप जब काई स्क्वायर निकाल रहे हो तो आपकी अल्फा वैल्यू कितनी है, उसके बेसिस पे यू कैन डिटरमाइन कि आपके पास टेबल में क्या एग्जैक्ट वैल्यू आ रही है. फॉर एग्जाम्पल हमारे केस में 5.99 आ रही थी. तो अगर आपको क्रिटिकल वैल्यू को कंपेयर करना है तो आप काई स्क्वायर वैल्यू से कंपेयर करोगे. अगर आपको पी वैल्यू कंपेयर करना है तो आप अल्फा से कंपेयर करोगे. आपका जो फाइनल रिजल्ट आएगा, जो फाइनल कंक्लूजन आएगा, वो दोनों केसेस में सेम आता है हमेशा. ये हमने डिस्कस किया एंड दैट्स द ओवरऑल डिस्कशन दैट वी हैड डन. फिर हमने एक और एग्जांपल लिया जिसको मैंने ऐसे आपको टास्क दिया, बट इसमें हमारा क्वेश्चन ये था कि एज और प्रोडक्ट के बीच में कनेक्शन है या नहीं, एसोसिएशन है या नहीं. वही सेम चीज हम डिस्कस कर रहे हैं. वी आर ट्राइंग टू कंपेयर द एसोसिएशन. अब कनेक्शन कब नहीं होगा? वो तब नहीं होगा जब इवनली स्प्रेड होगा डेटा. हर एक एज में जो लोग प्रोडक्ट्स खरीद रहे हैं वो सेम खरीद रहे हैं. कैसे खरीदेंगे? जब हमारे पास टोटल प्रोडक्ट काउंट कितना है, इलेक्ट्रॉनिक्स का 100 है, 3 कैटेगरीज हैं, तो डिवाइड बाय 3 करूंगी तभी इवनली स्प्रेड होगा. सिमिलरली क्लोथिंग के लिए, सिमिलरली होम गुड्स के लिए. एंड इससे हमारे पास में एक्सपेक्टेड डेटा आ गया. अब काम वही रहेगा, फिर से मैं ऑब्जर्व्ड माइनस एक्सपेक्टेड स्क्वायर डिवाइड बाय एक्सपेक्टेड करूंगी, सबका एडिशन करूंगी, मेरे पास काई स्क्वायर वैल्यू आएगी. उसको मैं कंपेयर करूंगी डिग्री ऑफ फ्रीडम के साथ. डिग्री ऑफ फ्रीडम इस केस में क्या होगा? इट विल बी नंबर ऑफ रोज. आई हैव 3 रोज -1 2. नंबर ऑफ कॉलम्स -1 3 -1 2. 2 into 2 is 4. तो इस तरीके से मैं उसे इवेल्युएट कर लूंगी. एंड वंस वी विल बी एबल टू गेट दैट वैल्यू, अगेन हम पी वैल्यू भी निकाल सकते हैं, हम क्रिटिकल वैल्यू भी निकाल सकते हैं, हम कंपेयर कर सकते हैं या तो अल्फा से या काई स्क्वायर वैल्यू से, एंड देन फाइनली वी विल रीच द सॉल्यूशन. इसको इम्प्लीमेंट करने के लिए मैंने आपको बताया कि क्योंकि हम यहाँ पे इंडिपेंडेंस टेस्ट कर रहे हैं, तो हमारे पास स्काईपाई के अंदर एक बड़ा इंटरेस्टिंग फंक्शन होता है, काई स्क्वायर अंडरस्कोर कंटिजेंसी। इसको हमें यूज करना है। इसको यूज करते ही आपके पास तीनों वैल्यूज आ जाएंगे। काई स्क्वायर की स्टैटिस्टिकल वैल्यू कितनी है, पी वैल्यू कितनी है, डिग्री ऑफ फ्रीडम कितना है, और एक्सपेक्टेड डेटा कितना है। एंड दैट्स व्हाट आई हैव शोकेस्ड यू स्टेप बाय स्टेप। उसके बेसिस पे, पी वैल्यू के बेसिस पे आप कंक्लूड कर सकते हो फिर से अल्फा को कंपेयर करते हुए कि आइदर यू आर रिजेक्टिंग और यू फेल टू रिजेक्ट इट। एंड दैट्स द होल थिंग दैट वी हैव कवर्ड अप टिल सो फार। अभी ठीक है? समरी मिल गई सभी को? अब तो क्लियर होना चाहिए, अब तो बहुत क्लियर होना चाहिए। ऑल गुड? काय स्क्वायर को क्लोज करें अभी?